Good afternoon, everyone. Welcome to our presentation on social good recommendation system of our team. Our client is DonorTools.org, which is a fundraising platform that connects high school teachers with potential donors to raise funds for their class projects. The goal here in our project is to increase recurring donations among donors by building a recommendation system and to increase proportion of fully funded projects by building a classification model. And for our project, we have scoped our data set to the geography of California for computation regions, and we're only considering repeated donors so that we could validate our recommendation system. In our content-based recommendation system, in our first approach, we have take first project. What it does is it takes the first project of any given donor and then tries to find projects that are similar to that first project and then test it in the remaining remaining projects that the donor has donated in order to validate if we have any hit. Moving on to the second approach is to find donor profiling approach. What it does is instead of looking at this one particular project and looking at all of the similar, it tries to aggregate all of the 80% of the donors past donated projects with the idea that the donor has propensity to donate has changed over time, and we want to aggregate those projects to create a profile per se, and the remaining 20% will be used for validation purposes.
We also built a collaborative filtering recommender system to find out similar donors and then recommend projects which are similar to those donors' past projects. We used a sparse matrix representation of the projects to build the donor profile on training data. The drawback with this recommender system is that we were using two levels of similarity, which resulted in poor recommendations, which were not very similar. So this reflected in the poor performance of our recommender system when we were evaluating it based on top K precision. When we are looking at the performance of the content-based recommender system, we observed the system 1 to perform better than the random recommender system. The ideal number of recommendations was 25, which gave us a precision of 0.116%. In business context, with the average donation size of around $65, our model could bring $109,000 of additional donations, which was capable of funding 148 additional projects.
One of our goals is to build a classifier that will predict the likelihood of our project being fully funded so that teachers are able to focus only on projects that have a higher chance of full funding. One of the problems we had was of class imbalance. Around 80% of the projects were fully funded and 20% were not. So we decided to check whether this imbalance negatively impacts our results by applying the techniques of undersampling and oversampling. After building our classifiers of random forest and logistic regression on these three different class data sets, we noticed that the results are similar. Therefore, we proceed with the assumption that class imbalance is not a problem. And since random forest gives us the highest AOC score, using the original training data, we would choose that model. Using a random forest algorithm, we identified three factors: project cost, project duration, and whether the project is technology-based to be the most significant predictors of funding success. The feature importance column that you see here mentions the variance explained by all the features. Of all the 400 plus features, these top three features explain around 70% of the variance in the project's funding success. Using these three factors only, we rebuild our classifiers with a max depth of 10 in order to avoid overfitting, and found no significant decrease in the AOC score for our random forest classifier. All in all, since teachers typically have many projects in parallel, our classification model can help them handpick the projects with the highest funding success, that too using only three factors. As for the recommendations, we recommend that we use CBRS as 1 for one-time donors and CBRS2 for recurring donors, and we add the funding success probability feature on the teachers portal on the website. Thank you.